Hello everyone, welcome back. Have you ever wondered how a complex graph can be organized without creating confusing edge crossings? In graph theory, this problem is studied through book embeddings. A book embedding places all vertices along a single line called the spine, while edges are assigned to different pages so that edges on the same page do not cross. The minimum number of pages needed reveals important structural properties of a graph. In this video, we'll introduce the concept of book embeddings and explore the way of using it. Now we move on to the demonstration of book embedding in graph theory. We begin with the original graph, consisting of 6 vertices connected by multiple edges. Our objective is to represent this graph as a book embedding. First, we observe the graph in its original form. This allows us to identify all vertices and edge connections before any transformation is applied. Next, the vertices are rearranged onto a straight horizontal line. This line becomes the spine of the book. At this stage, the graph structure remains the same, but the vertices now follow a linear ordering. Now let's take the edges that wraps the graph all around. Most of those edges would make a straight line of the book called the spine. Except one edge, which is the edge that connects the vertices 1 and 6, would be put up on top. This half-circular line on top would be known as the edges on page 1. Let's associate edges on page 1 as the color of red. Next, let's take every edges that connects vertices 1 to other vertices that hasn't been used in the book embedding. There are 3 other edges with each of them connects vertices 1 to 3, 4, and 5. As again, these edges now will be known as the edges on the first page. Now we'll move on to the edges that connects the vertices 2. But in this condition, we cannot put any more edges on the top or we would have a crossing. To prevent that, we put these edges on the bottom instead. Now these edges on the bottom will be known as the edges on page 2 and we'll associate them with the color yellow. Next, for the edges that connects vertices 3. Again, we cannot put any more edges on page 2 or that would be a crossing. So, we put these edges again on top, but it will be known as edges on the page 3 instead, and technically it is not crossing with the edges on page 1. We'll associate these edges on the page 3 as the color green. Lastly, we only have one more edge, which is the edge that connects vertices 4 and 6. Same way as we did for the other edges and pages, this edge will be putted on page 4. Let's associate page 4 with the color purple. And finally, we have a whole graph without any crossing at all using the book embedding with a total of 4 different pages. Thus the explanation of book embedding in this video. Thank you.